Okay guys, today we'll be doing 6.2. We're going to continue factoring, and today we're going to talk about basic factoring and bottoms up. But before we get into factoring, let's walk through one more time what the steps of factoring are. Anytime I ask you to factor or solve by factoring, you should be following the same 6 steps every single time. The first step, always make sure that your equation is in order and all to the same side. So make sure everything is in order and all to the same side of your equal to sign if there is an equal to sign. We talked about yesterday, the next step after I have it in order is to look for a GCF. Is there a greatest common factor, a number or a variable that you can take out of everything? And if there is, you need to take it out first. Okay? The next step happens if there are 2 terms. We're going to talk about squares and cubes. This happens again if there are 2 terms in your problem. We'll talk about that later. The next 2 steps, 4 and 5, happen when there are 3 terms. That's actually what we're going to talk about today. How do you factor something that has 3 terms in it? Well, you're either going to do step number 4 or step number 5. Step number 4 is basic factor. If there are 3 terms, you're going to try to basic factor it. If there are 3 terms and you can't basic factor it, well then you're going to do a method called bottoms up. Bottoms up is just a factoring method. You might have learned guess and check. You might have learned, I've seen some kids do some sort of a box something or other, I don't know. But the method that I use is called bottoms up. You might have heard it in some of your other math classes, especially Mr. Youngbird's class. I like this method because it works all the time and there are certain steps to follow. So I like the bottoms up method. We talked the other day too about what to do if you have 4 terms, or more than 3 anyway. If you have 4 terms in your problem and I'm asking you to factor, you have to use what method? Grouping, right? Okay, so in order, GCF, squares and cubes, which we haven't talked about yet, but we will. If there are 3 terms, you're either going to basic factor or bottoms up. And if there are more than 3 terms, let's say there's 4 terms, then you're going to try to factor by grouping. Make sure that you know these 6 steps. Anytime you ask me what you're supposed to do, I'm going to ask you to walk through these 6 steps because you should be able to follow factoring by looking at these 6 steps. Okay? Let's do some problems. Here's our first problem. Here's do them with me number 1. If I ask you to factor, I have a y squared plus 2y minus 35, and we need to factor it. My first step in factoring is to make sure that it's in order. It looks like it is. I have my y squared first, then my y, then my number. My next step is to look for a GCF. Can I take out a y from every single one of those terms? Look carefully. That 35 doesn't have a y with it, right? So I can't take out a GCF. I can't take out a number from all of my different terms. We don't take out ones because that doesn't change much. So there's no GCF, no number, no variable that I can take out of everything. How many terms does this question have? Well, if you look closely, it has 1, 2, 3 different terms. Since there are 3 terms, I'm going to try to basic factor. What I'm doing here, basic factoring, is kind of like the opposite of foiling. So I need to make it look like a FOIL problem. I need to break up this problem into 2 smaller pieces. So I'm going to start with this y squared. And if I want to take this y squared and break it up into smaller pieces, can I put a y here and a y here? So that way, if I were to FOIL, what's y times y? I get y squared, right? Okay. The next thing I need to do is figure out what numbers go inside next to my y. I need to figure out 2 numbers that go inside that when I FOIL it, I'll end up getting the 35, the negative 35, and the positive 2. So in order to find those 2 numbers, you need to figure out what 2 numbers multiply to negative 35, but when you add them together, you get positive 2. We need 2 numbers that multiply to a negative 35, that when you add them together, you get positive 2. You should end up getting a positive 7 and a negative 5, right? They multiply to negative 35, that they add together to give you positive 2. This would be the factored version of your problem. You could always double check by FOILing it back out. When you FOIL it back out, you should get the problem that you started with. Okay? Let's look at B. B says m squared plus 6m plus 7. It's in order, right? M squared, then my m, then my number. There is no GCF though. I can't take out an m from everybody, and there's no GCF, no number I can take out of everybody. No GCF. There are 3 terms in this problem, so let's try to basic factor. If I were to try to basic factor this one, can I take the m squared and break it up into m and m? But then I would need 2 numbers that multiply to 7, that when I add them together I get 6. Not the opposite way around. Make sure you're multiplying to the last number, the 7, and you're adding to the middle number, the 6. So what combination of numbers, what 2 numbers is going to give you a positive 7 when you multiply, but a positive 6 when you add them together? Now be careful. It needs to multiply to a positive 7. So if I choose 7 and 1, that multiplies to 7, but what does it add to? Doesn't it add to 8, right? And I don't want 8, I want a 6, so it can't be that. What if I chose negative 7 and negative 1? Wouldn't that still multiply to give me positive 7? But what does that add to? Doesn't it add to negative 8? And I don't want a negative 8, I want a positive 6. So is there any other combination of numbers that's going to multiply to give me positive 7 but add to give me 6? Now be careful, if I made this a positive 7, that would add to 6, wouldn't it? But what would it multiply to? Wouldn't it multiply to a negative 7? And I don't want a negative 7, I want a positive 7. So in this problem can't actually be factored. I'm going to call this problem prime. Sometimes you will get problems that you cannot factor. Not all the time, so don't tell me your whole homework is prime. But sometimes you do get problems that can't factor, so we're going to call it prime. All right, let's do another one. Let's look at this one. I've got p squared plus 6ap minus 16a squared. I guess it's kind of in order. It's kind of hard to tell. I mean, I guess you could move around the a's and the p's. It's kind of hard to tell though in order, so let's just leave it the way it is. Is there a GCF? Is there a p that I can take out of everybody? No, that last one doesn't have a p, right? Is there an a that I can take out of everybody? No, the first one doesn't have an a. And there's not a number that I can take out of all my terms. If you look, how many terms are there? Looks like there's 3, right? If there are 3 terms, I'm going to try to factor. I'm going to try to basic factor. That means I want to break it down into smaller pieces. So let's do like we did before on the other examples. If I take this p squared, how can I take a p squared and break it down smaller? Can I do a p here and a p there? We're going to do the same thing that we did before. I need numbers that multiply to negative 16, that when I add them together I get positive 6. So what numbers multiply to negative 16 that add to give me positive 6? Can I say positive 8 and negative 2? Doesn't that multiply to negative 16 and add to 6? The only difference on this problem is you have an a squared in the back. Just like you had a p squared in the front, we broke it down. Can I take the a squared in the back and break it down? So can I take this a squared in the back and change it to, or break it down to a and a? That's it. That's your factored problem. If you were to FOIL it out, you should end up getting the p squared plus 6ap minus 16a squared. So if you have the squared, you just break them down into the front or the back, depending on where they're at. Let's do one more. I've got a 16y cubed minus 32y squared minus 48y, and I want to factor. My first step in factoring is to make sure that everything is in order. And since it goes y cubed, then y squared, then y, it looks like it's in order. My next step is to see if there is a GCF, the greatest common factor. Looking at this problem, is there a number that I can take out of 16, 32, and 48? And I want the biggest number. Can I take out 16? What else can I take out of all these terms? Can I do a 16 and a y? If I take out a 16 and a y, let's see what's left over. If I take out a 16 and a y, what's left over in this first term? It looks like a y squared. Minus, if I take out a 16 and a y, what's left over in my middle term? 32 divided by 16, is that 2 plus another y, so 2y? Minus, how many times does 16 go into 48? Is that 3? I took out the y, so that would be my leftovers. That is not your final answer. How come? Can I still factor on the inside here? If I can factor, I need to factor down as far as possible. Okay? This has 3 terms in it. To me, this looks like a basic factor problem. Don't forget about your GCF in front. That is part of your answer, so make sure you carry that 16y down. Let's basic factor the inside, though. Let's break up the y squared into y here and y here. What numbers multiply to negative 3? that when you add them together, you get -2. Multiply to -3, add to -2. Can I say -3 and +1? That would be your factored answer. Again, make sure you don't forget about your GCF. The 16y is part of your answer, so please make sure that you carry it down. You will get points marked off if you don't have your GCF out in front. Okay? So that's basic factoring. If there was 3 terms, we need to try and break it down by basic factoring. Okay? Sometimes, though, basic factoring doesn't work. Let's look at this problem. Here's example number 1. It asks us to still factor, and it gives me 12r squared minus 5r minus 2. How does this problem look different than the last couple problems that we did, the last couple examples? It's still in order, right? There's no GCF. From 12, 5, and 2, there's no GCF. And there's 3 terms, but how is this one different? Isn't this one different because there's a number in front? Right now there's a 12. If you look back at all the other examples we just did, there was no number in front, or you can say an invisible 1. Since there's 3 terms in this problem, and there's a number in front that you can't GCF out, this is when you're going to do bottoms up. Okay? You know that there's a saying for order of operations, please excuse my dear Aunt Sally. Well, I've come up with a saying for bottoms up. You can use it if you'd like. You can make up your own saying. But the saying that I have for bottoms up is, my friend doesn't read books. My friend doesn't read books. Those letters stand for certain things. Let's talk about what they stand for. Okay, so MFDRB, my friend doesn't read books. Let's talk about what each of those letters represents. The M represents multiply. What I'm going to do, because there's a number in front here, is I'm going to take this number and I'm going to multiply it by the last number. That gets rid of it in the front, leaving me with an r squared minus 5r, and then makes this 2, this -2, actually a -24. -2 times 12 is -24. Okay? The F represents factor. This is now turned into a basic factor problem, where I can break this down into 2 small parentheses, breaking your r squared down into r and r. Then you need to figure out what number is multiplied in -24. That when you add them together, you get -5. You should end up getting -8 and +3. Now this is the most common mistake that I see, because this looks done, right? It is not done though. So if you need to write out these 5 letters and check them off every single time that you do it, the most common mistake that I see is that you forget to divide, reduce, and bottoms up. Okay, that's the last 3 steps. The D means divide. If you go through and multiply something by 12, you have to go back and balance it out by dividing things by 12. So you're going to divide everything by what you multiplied by in the first place. So in this case, it would be the 12. Okay? The R represents reduce. I'm going to go through and reduce these 2 fractions. 8 over 12 reduces to what? 2 over 3. And 3 over 12 reduces to 1/4. So I'm going to go through and reduce. My last step, the B, stands for bottoms up. I've got bottoms on my fractions, denominators, right? I've got to take these bottoms and I've got to bring them up. So I'm going to take this 3 and move it in front of my r, changing it to a 3r minus 2. I'm also going to take this bottom, this denominator, and move it up in front of this r, making it a 4r plus 1. This is the factored version of my problem. You could FOIL it out to make sure, but when you do FOIL it out, you should end up getting back your 12r squared minus 5r minus 2. Okay? That's bottoms up. Let's do one more of the bottoms up ones. Let's go back here. If you look at example, what is this, number 2? Example, this is example number 1b. What I would do on this one, I'm not going to do this one. What I would do on this one, though, if you were to do it, is I would make sure to factor out this negative. Okay? Factor out a negative first, change all your signs, and then go through with your bottoms up. If you don't, that's going to mess up some of your signs in the end. Okay? So factor out a negative so that your leading coefficient, so that your beginning number is always positive. Okay? It would be something like this. And then you can do bottoms up with the inside stuff. okay? But make sure that negative stays out front because it will make a difference in your final answer. Okay, I'm going to go ahead and skip that one. Let's look at this one here. Okay, this one looks kind of complicated. There's some parentheses, there's a squared, there's a couple terms. I do not want to FOIL. FOILing is opposite of factoring. So I don't want to take that x plus 3 squared and FOIL it all out, distribute it to 2, and take the 5 and distribute it. I don't want to FOIL, okay? But what I can do is try to make this look a little bit more simplified, make it a little easier to deal with. You see how this has an x plus 3 in it, and this has an x plus 3 in it? Since they're both the same things, can I take those out and call it whatever I want? So I'm going to, off to the side, I don't know, I'm going to use D for Devaney. I'm going to call x plus 3 D. So instead of having an x plus 3 in here, I'm going to call this D instead. So now this turns into a 2D squared. That means I'm going to take this x plus 3, and I'm going to change it into a D. So now I have plus 5D minus 12. Doesn't that problem look a little bit better to deal with? Doesn't have all that stuff in it, doesn't look as complicated. So if I give you that problem, 2D squared plus 5D minus 12, it's in order, there's no GCF, there's 3 terms, and there's a number in front. So how do I factor if there's 3 terms and a number in front? Well, here's a bottoms up. Let's do it. My friend doesn't read books. Here we go. Let's take this 2 away. Let's multiply it by the 12, giving me a D squared plus 5D minus 24. That's my multiply. What does F stand for? Factor, right? Let's go through and basic factor this guy. I'm going to break down my D squared into D and D. I need to figure out numbers that multiply to negative 24 that add to positive 5. Ooh, those are the same numbers as before. So can I do a positive 8 and a negative 3? Okay, that's my factor. Don't forget to divide, reduce, and bottoms up. So in this problem, what did we go through and multiply by? Looks like we multiplied by 2 this time. So I need to go back and divide everything by 2. I'm going to reduce. 8 over 2 reduces to 4. And 3 over 2 doesn't reduce, so is it okay if I bring this bottoms up right now? So I have a 2D minus 3. Now that's not my final answer, because D doesn't really represent D. If you remember back at the very beginning, what does D really mean? Doesn't that mean my x plus 3? So instead of a D, I'm going to plug in an x plus 3. So I have an x plus 3 plus 4, and then a 2 times x plus 3 minus 3. Okay, so now I'm going to take back out my D's, and I'm going to plug back in my x plus 3. I'm going to simplify inside both of these parentheses. Sorry, I'm running out of room. I'm going to move it over here. This first parenthesis then changes to x plus 7. When I combine the 3 and the 4, it becomes a 7. I'm going to distribute the 2 through in this next set of parentheses, giving me a 2x plus 6 minus 3. So then when I combine like terms there, I get a 2x plus 3. This would be the factored version of your original problem. Okay? So if there's something in your problem that you can take out and call it another letter, whatever letter you want to choose, D, you can do X again if you want to, just make sure that in the very end, that anytime you see a D, you resubstitute it back into what it really represents. Okay? I'd like you to try one more of these, this last one. Will you do D for me, please? You have 6y to the 4th plus 7y squared minus 20. Now you're going to do it the same way. There's only one little baby difference. So why don't you start, and I'll catch up with you in a second. Okay, there's 3 terms. It's in order. There's no GCF, no number I can take out of 6, 7, and 20. There's 3 terms and a number in front, so I'm going to bottoms up. My friend doesn't read books. I'm going to go through and multiply by 6. I have a y to the 4th plus 7y squared minus, what's that, 120? All right, these numbers are a little bit big. I need to figure out what numbers multiply to 120 that add to 7. You might need to try a few. Here, I'll help you out. You should get positive 15 and negative 8. Now look at this problem carefully. There is a little bit of a difference here. There's a y to the 4th, right? If I'm trying to do my basic factor like before, normally I'm only used to taking a y squared and breaking it up. But what if it's a y to the 4th? Can I still break it up? And can I still break it up evenly? So how do you think I'd be able to take a y to the 4th and break it up evenly? I do y squared and y squared. Doesn't that work? Right? If I were to FOIL it back out, y squared times y squared is y to the 4th. So we're doing the same exact thing. The only difference is instead of a y plus 15, we have a y squared plus 15. Do not forget to divide, reduce, bottoms up. We've got to do these last 3 steps. So what are we going to go back through and divide by? By the 6. Let's reduce. Five halves. 4 goes, 3 goes, 2 goes into there, 4, 2 goes into there, 3, 4/3. And don't forget to bottoms up. Bring your 2 forward, bring your 3 forward. Your final answer then would be 2y squared plus 5 and 3y squared minus 4. This would be the factored version of your problem. Okay? Make sure you follow the 6 steps in factoring. Put it in order. Look for a GCF. See how many terms there are. If there are 3 terms, you're either going to basic factor or bottoms up. Remember, we bottoms up when there's a number in front that you can't GCF out. Okay? Practice this today.